Assalamualaikum warahmatullahi wabarakatuh. Okay, right now I will show to you a new program how to simulate maybe a real world scenario, real world measurement using Python. So in the previous meeting, I already showed to you how to install PIP. PIP is a command for easily install another library plugin for our Python environment. So that's why we need PIP. So after we can have the PIP, so in our next project, we need install visualization program, visualization plugin in our Python environment. So the name of the library is Plotex. So we type pip install Plotex and then just install. After we install the Plotex, so we can start our new program, new file and Python file, and then we can save first, save as to our in our folder here. Maybe we can name the file week 14, enter. Oh, I already have week 14, so just replace, no problem. Okay, after we install and start a new project, we import. Import Plotex and then enter. And then the real world measurement that I will teach to you how to simulate it is the power system in our country, which is supplied by PLN. Now, different country has a different unique characteristic of the power distribution line. In our country, we have 220 volt AC voltage, and also 50 Hz frequency. And this type of wave is in form of sinus. So how we can simulate this program? So the voltage equals to A time sin omega times T. This is the continuous formula for the voltage in real world scenario. So we need to convert this continuous form into the discrete form using our Python. So in our Python, we need to know that the computer is used the discrete programming, discrete system. So that's why we need to describe first. We have the fee in the list. Okay, we have fee, and the fee is list in Python, and we need to put the numbers that represent v equals to a times sin w times t. So that's why maybe I will use this variable temp equals to a, okay, times sin, and w we can derive the w or omega, and the omega is equals to 2 times p 3.14, right? And then times the signal frequency, which is 50 hertz. Okay, then we need to times 2pf times t. T can be derived from the frequency of sampling rate. So the t equals to I divided by frequency sampling. I is the step, the number of sampling divided by frequency sampling. So we need to define each variable. A equals to 220, and then sin, the sin is cannot be used because it is not defined by Python environment. So that's why we need to import math. So we can, the math have the function sin. So that's why we can include the sin in our math library. And also p. So math.p. Okay, and we need to define f. F equals to 50. And then frequency sampling frequency equals to, maybe we want to sampling the 50 hertz using more than 2 times f. So basically, the higher the frequency sampling, the better. So the representation of continuous signal can be visualized better rather using just only few low frequency sampling. So that's why the minimum frequency sampling is 2 times f, the minimum, which is 100. But for the since frequency, we need to achieve higher frequency sampling. So maybe we can set it using 1000, and then we want to use n sample, how much sample that we want to create it, maybe 100. Okay, and there is one variable that still not defined, which is I. So using for I in range from 0 to n sample, and then we define temporary equals to this equation, and then temporary can be inputted into the list. So we can fill the list, insert constant into the list using the list is v dot append and then temporary. So that's it. After that, we can also print the v I. Okay, and then just run it. We save and run, and then we have this number that represent our signal. Okay, and how we can show or visualize this number, because it's quite difficult if we just print each number. So we can call the plottext dot plot v, and then plottext dot show, and we can run it. Oh, don't forget to save and run. Okay, that's it. We can simulate the signal, our power line signal, using Python programming language. So that's all. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.